Go ahead.
Hello, good morning, everyone. My name is Qiwei Zhang. I come from the Department of Chemical and Materials Engineering. And I'll talk about the metal rolling. In this presentation, including 6 sections: introduction, classification, rolling process, application, and my research and conclusion. What is rolling? In metal working, rolling is a metal forming process in which metal stock is passed through a pair of rolls to reduce its thickness and transform the cross section. This picture shows how to make the noodles by a rolling pin, and this left picture is the principle of flat rolling. Does it look like making dough to for the noodles? The rolling mill and the rolling pin work on the same principle. And the red picture is about steel rolling. We can see the steel exceeding from the rolling mill. The invention of the rolling mill is attributed to the Leonardo da Vinci. I'm amazing he's not only a painter. With the rolling mill, it's possible to shape metals. The revolving cylinders press and level out the metal sheet in an even way. This device is well fit and is still used today without significant variations. There are some rolling mills picture. Metal rolling operations can produce a wide range of products. The width of the road work can be as much as several meters, or narrower than thousandths of an inch. For the thickness, the metal plates can be rolled to a thickness of 12 inches, while foil can be rolled into the thickness of 0.0003 inch. The rolls used in the rolling mills are of various sizes. In flat rolling, the rolls can typically be 24 to 54 inch in diameter. And in some other rolling operations, such as in the forming of very thin work, the rolling can be as small as 0.25 inch. And there are many types of rolling processes. This is the ring rolling, the roll bonding, the roll forming, and the structural shape rolling, and all of these are based on the flat rolling. In general, the rolling is classified by the temperature of the road work. If the temperature of workpiece is above the recrystallization temperature, this process is termed as hard rolling. Because the high temperature, there is no strain hardening, and the metal has a far greater ductility. Because of these two reasons, the hard rolling requires much less force and power to shape the metal. And there also are some disadvantages, including poor surface finish, scale, oxidize, lower dimensional accuracy, and the need to heat the workpiece. And if the temperature is below the recrystallization temperature. This process is termed as cold rolling. Cold rolling can increase strength via strain hardening up to 20%, and it also improves surface finish and hosts tighter tolerances. The cold rolling do not require heating of the workpiece, so a large amount of energy can be saved, and faster production is possible. But there has still three disadvantages about cold rolling. The first, cold rolled work are usually smaller, and second, cold rolling cannot reduce thickness of a workpiece as much as hard rolling in a single pass. And third is cold rolling will decrease the ductility. This is the principle of flat rolling. We can see in the most rolling operations are similar. We can see this. We can see in this picture, a workpiece is plastically deformed by compressive forces between these two constantly spinning rolls. This force acts to reduce the thickness of metal and affect its grain structure. And these two rolls also act to fit the material as they spin in opposite directions to each other. And in this picture, we can see the final thickness is less than the initial thickness, and the final width is greater than the initial width. In metal rolling operations, the plastic deformation causing a reduction in thickness will also cause an increase in the width of part. This is called spreading. When the workpiece has a high width to thickness ratio, the increase in width is very small. But in cases of low width to thickness ratio, such as a square cross section, the spreading is a big problem. As this picture, we can use vertical rolls to add the workpiece and maintain a constant width. This picture shows the microstructure. At a high temperature, the hard rolling can convert the cast grain structure to the rough grain structure. The initial material has non-uniform grains, typically large columnar grains. This grains boundary are very weak, so this structure is brittle. But in the high temperature, the hard rolling can break apart this old grain structure and reform a new one. This new boundaries is very stronger in the small and more uniform grain structure. For the flat rolling, if the thickness of the products is more than 6 mm, it can be applied to the body of the ship and boiler and the bridge and the containers of nuclear reactions. If the thickness of the products less than 6 mm, it always be applied to aircraft skin and household appliances and beverage containers. Apart from the steel rolling mill can also be used for some other applications. For example, part rolling is a sheet metal fabrication process used to produce several thin film sheets at the same time. And this picture is a leveling rose. Leveling is achieved by precisely bending metal strip back and forth as it passes through a series of small diameter offset rows. At the beginning of the several rows, the gap is very small, and it will bend the sheet every time to erase the memory of the sheet. And at the end, the several rows will reset the memory to flat as the sheet leaving of these leveling rows. And my research is about row bending. At the beginning, the two metal sheet will cut, and I will do the surface treatment for them. For example, the upper one is a copper sheet, the bottom one is a aluminum sheet, and then of the thickness of them is about 1 millimeter, and then they are get together and do the heat treatment, and final I'll feed them into the rolling mill, and they will roll bending to a bimetal. This is a bimetal. The thickness of this bimetal is about 1 millimeter. So the reduction is 15%. And the bimetal has a lot of improvement properties, such as high strength and high ductility or high hardness. The final, this bimetal will cut to the two pieces in the middle, and repeat all these steps several times. And finally, the sample will become the multi-layer metal. The sample I prepared is more than 200 layers. So my future work is to test these samples with the different conditions, the different heat treatment conditions, and the different various annealing conditions. In conclusion, the metal rolling is one of most important manufacturing process in the modern world, and the advantage of the metal rolling not only in the creation of useful geometric forms, but also in the creation of desired material properties. That's all. Thank you. Hi.
For your work, are you going to be heating or annealing between each individual layer, or just after you, like you said, you had 200 layers? It's impressive. Are they all going to be bonded the same?
Yeah, I will prepare a lot of sample. If one sample is cannot work, I can use another to replace this. Yeah. So maybe the initial sample will more than 21, will more than 20 pieces, and the final just left one. Yeah. And any others? Okay, thank you.